Okay students, now let's start a new chapter number 6, fractions. So let's learn some new concepts about fractions. Fraction as a part of a whole. Fraction means a part of a whole. Take a cutout of a circle and divide it into two equal parts. Shade one part. This shaded part, one half of the whole. So we call it half and read it as 1 by 2 or even 1 over 2. It is represented as 1 on 2. Similarly, take a cutout of another circle and divide it into three equal parts. Shade one part. This shaded part is 1/3 of the whole. So we call it 1/3 and read it as 1 by 3 or 1 over 3. In the similar way, we represent different fractions. As you can see here, shaded part, first circle that is divided into three parts is 1 upon 3. And unshaded part is equal to 2 upon 3. In the second circle it has been divided into 4 equal parts. Shaded part is equal to 1 by 4 and unshaded part is equal to 3 by 4. The third circle, it has been divided into 8 equal parts. Shaded part is 1 by 8, shaded part is 7 by 8. Smart tip: 2 halves make a whole, 3/3 a whole, 4/4 whole, and so on. Fractions and fractional numbers. When numbers are represented in figures or symbols like 1 by 2, 1 by 3, 2 by 3, 1 by 4, 1 by 5, etc., they are called fractional numbers. As you can see here in the first figure, we have divided the figure into 7 equal parts. Shaded parts are 4 parts out of 7. So the fraction is 4 by 7 and the fractional number is 4/7. Similarly, in second figure, it has been divided into 8 parts and the shaded part is 1 part out of 8. So the fraction is 1 by 8 and the fractional number is 1/8. Numerator and denominator of a fraction. Fraction is always written with two numerals arranged one over the other and separated by a line. The numeral above the line is called the numerator. The numeral below the line is called the denominator. So the fraction is equal to numerator upon denominator. For example, 7 by 9, we have numerator equals to 7 and denominator equals to 9. Similarly, in 2 by 3, numerator equals to 2 and denominator equals to 3. So students, now we are going to start our new chapter number 6, fractions. So now let's look at our example number 1. Shade the fractions as specified in each of the following. So our first question is, we have to shade the given figure in the form of the fraction 1 upon 2. So you have to shade according to this fraction, that is 1 upon 2. It means that figure should be divided into two equal parts and out of the two equal parts we have to shade the one part. So we have shade two equal parts and we have to shade only this part. As I have shown here, the shaded part is one part out of the two equal parts and fraction is 1 upon 2. So I hope students you have understood how to shade when the fraction is given. First we need to look for the equal number of parts, that is 2, and out of 2 we have to shade one part as I have done here. So students, now look at example number 1, B part. In this we are given a figure and the figure has been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 equal parts and we need to shade it according to our fraction 2 out of 9. So 9 means total number of parts as it has been divided into 9 equal parts. So out of 9 we have to shade only 2 parts. So our answer would be, so we have shaded the 2 parts and this is our shaded fraction 2 by 9. So I hope students you have understood how to shade when a fraction has been given. First we need to look for the total number of equal parts and out of that the number of parts to be shaded is written above. Fractional parts of a collection. Ankit has a collection of 16 volleyballs. He was told to sort out 3 by 4 of this collection. How would he do it? He needs to divide total 16 volleyballs into 4 equal parts. Thus, each part has 4 volleyballs. If he wants to take 3 parts, then he would write 3/4 part of the volleyballs. Thus, 3 by 4 or 16 is equal to 12 volleyballs. So students, now looking at our example number 1, find 1/4 of the following collection. So we are given a figure and we have to find 1/4 of the given figure. So 1/4 means it has to be divided into 4 equal parts. So since there are 4 parts, so we can say 1/4 of 4 is equal to, so 1/4 means total number of parts 4 and out of that 1 part, so total parts are 4 and 1 part means 1 square. So 1/4 of this figure is 1 square, or I must say 1 square is 1/4 of the given figure. Fraction on the number line. Fractions can be represented by points on the number line. Let us represent 1/5, 2/5, 3/5 and 4/5 on the number line. Step 1. Draw a number line and mark 0 and 1 on it. The line segment between the two markings represent the whole. Step 2. Divide the number line between 0 and 1 into as many parts as the number in the denominator. Here, the denominator is 5, so the line segment representing one whole is divided into 5 equal parts. Label all the 5 parts. The first mark represents 1 out of 5, so write 1/5. The second 2/5, then 3/5, 4/5 and 5/5. You can see here in the diagram. Types of fractions. Now let us learn different types of fractions. Like fractions. Fractions with same denominator are called like fractions. For example, 1/4 and 3/4 are like fractions. Unlike fractions. Fractions with different denominators are called unlike fractions. For example, 1/4 and 1/8 are unlike fractions. Proper fractions. Proper fractions. If the numerator of a fraction is less than its denominator, it is called a proper fraction. Therefore, the value of a proper fraction is always less than 1. For example, 1/2, 2/3, 3/4, 4/9, 8/13, etc. are all proper fractions. Improper fractions. Fractions with the numerator either equal to or greater than the denominator are called improper fractions. Therefore, the value of an improper fraction is either equal to or greater than 1. For example, 5/5, 3/2, 8/3, etc. are all improper fractions. Unit fractions. A proper fraction with 1 as its numerator is called a unit fraction. For example, 1/7, 1/5, 1/4, etc. are all unit fractions. Mixed fractions. A combination of a whole part and a proper fraction is called a mixed fraction. As you can see here in diagram, we are given 2 whole parts that has been divided into 3 equal parts. And the third whole parts, as you can see here, we are given 3 parts. As you can see here in the diagram, we are given 2 whole parts and a fractional part. So 2 whole parts situate as 1 plus 1 plus 1/3, that is fractional part. So our fraction becomes 2 plus 1/3 is equal to 2 1/3, that is a mixed fraction. 2 plus 1/3 is an expanded numeral, 2 1/3 is a compact numeral, where 2 is a whole part and 1/3 is a proper fraction. Similarly, 1 1/3, 2 1/5, 7 1/7, etc. are all mixed fractions. Conversion of mixed fraction into an improper fraction. We can express a mixed fraction, say 2 1/3, as an improper fraction by following steps. Step 1. Multiply the whole number by the denominator of the fraction, that is 2 multiplied by 3 is equal to 6. Step 2. Add the product to the numerator, that is 6 plus 1 equals to 7. Step 3. Write the number obtained with same denominator, that is 7/3. Thus, 2 1/3 is equal to 7/3. Conversion of an improper fraction into mixed fraction. We can express an improper fraction, say 5/3, as a mixed fraction by following steps. Step 1. Divide the numerator by the denominator. As you can see here, step 2. Write the remainder over the original denominator and the quotient as whole number. Thus, 5/3 is equal to 1 2/3. So students, let's look at our example number 1. Write all the like fractions from the following group of fractions. So we are given some fractions. From this we have to find the like fraction. First of all, we will learn what is a like fraction. So like fraction are the fraction which have the same denominator. So here we will look for the numbers having the same denominator, that is 2 by 3, 7 by 3 and 1 by 3. So these are the like fractions. Since 2 by 3, 7 by 3 and 1 by 3 have the same, since 2 by 3, 7 by 3 and 1 by 3 have the same denominator, so we can say 2 by 3, 7 by 3, 1 by 3 are like fractions. So students, since 2 by 3, 7 by 3 and 1 by 3 have same denominator, that is 3, so we can say 2 by 3, 7 by 3 and 1 by 3 are like fractions. Equivalent fractions. Observe the three rectangles carefully and write the shaded parts as fractions. Clearly, the shaded portion in each rectangle represents the same part of the rectangle. So 1 by 2, 2 by 4 and 4 by 8 are equivalent fractions. Equivalent fractions are the fractions that represent the same part of a whole or a collection. So they are equal in value. Finding equivalent fraction. To get a fraction equivalent to a given fraction, we multiply or divide the numerator and the denominator of the given fraction by the same number, except 0. Checking equivalent fraction. Multiply the numerator of first fraction by denominator of second fraction and denominator of first fraction by the numerator of second fraction. If the products are equal, the fractions are equivalent. If numerator 1 upon denominator 1 and numerator 2 upon denominator 2 are two fractions, then n1 into d2 numerator 1 into denominator 2 is equal to d1. If n1 upon d1 and n2 upon d2 are the two fractions and n1 into d2 is equal to d1 into n2, both of these fractions are equivalent fractions. This method is called the cross multiplication method. So students, now look at example number 1. Write 4 equivalent fractions of 3 upon 5. So our fraction is 3 by 5. So we need to multiply both numerator and denominator with the same number. So let's multiply numerator and denominator by, we can select any number, suppose 2, 3, 4 and 6. So let's start 3 upon 5 into 2 into 2, 6 upon 10. So our first equivalent fraction becomes 6 upon 10. Similarly, again 3 upon 5 we multiply by 3 on numerator and denominator, we get 9 upon 15. Now 3 we have taken multiply by 4, numerator also multiplied by 4, whereas denominator also we multiply by 4. So we get 12 upon 20. So this is our third, and at last 3 upon 5 into, we have taken 6, multiplying by 6 on numerator and denominator, we get 18 upon. So these are our 4 equivalent. So students, these are our 4 equivalent fractions: 6 by 10, 9 by 15, 12 by 20 and 18 by 30 of the given fraction 3 by 4, 3 by 5. So I hope you have understood how to find the equivalent fraction. One thing to keep in mind, that numerator and denominator has to be multiplied by the same numbers, and we can take any number to multiply with numerator as well as denominator. Comparison of fractions. When the denominators are same, To compare the fractions with same denominator, we simply compare their numerators and arrange them in the required order. The fraction with the greater numerator is greater than the other. When the numerators are same, to compare fractions with same numerator, we simply compare their denominators. The fraction with smaller denominator is greater than the other. So students, let's look at example number 1, which is smaller, 3 upon 7 or 5 upon 7. So we are given the two fractions and we have to compare the two fractions and find out which one is smaller and which one is greater. So to find that, as we can see in this question, the two fractions have the same denominator. Since the denominators are same, so we need to compare. So comparing numerators. So since denominators are same, we need to compare numerators. That is, since numerator 3 is less than 5, so we can say the fraction with numerator 3 is less than the fraction with numerator 5. So since 3 is less than 5, therefore 3 by 7 is less than 5 by 7. So you can say 3 by 7 is smaller than 5 by 7. So students, I hope you have understood how to compare the two fractions when they have the same denominators. We need to compare only the numerators. The greater the numerator, so the fraction will be greater than the other fraction. If the numerator is smaller than the other numerator, so the fraction with smaller numerator will be smaller than the other. Addition of like fraction. Let us understand the addition of like fraction by doing an activity. Represent 1 by 5 on a paper strip. Represent 3 by 5 on another paper strip. Add the numerators of both the fractions, that is 1 plus 3 equals to 4, and represent on the strip shown here. Thus, 1 by 5 plus 3 by 5 is equal to 4 by 5. Sum of two or more like fractions is equal to sum of the numerators upon common denominators. So students, now let's look at example number 1. Add 2 by 9 and 5 by 9. So here we are given two fractions and we have to add this fraction. As you can see, both the fractions have the same denominator. So we can say the two fractions are like fractions. So to add the like fractions, what we need to do? We need to first write 2 by 9 plus 5 by 9. Now both have the same denominator. So what we need to do? We need to search. We need to take a common denominator, since the common denominator is 9, and add up the numerators. So common denominator is 9 and the numerators are added. So 2 plus 5. Now when we add the numerators, 2 plus 5 is 7. So our answer is 7 by 9. So this is the answer for the required addition of the two fractions, that is two like fractions. So I hope students you have understood how to add two like fractions. What we need to do? We need to just add up the numerators, and in denominator we need to keep a common denominator, since the denominators are same in both the fractions. So have a common denominator and numerators are added together. Subtraction of like fractions. Subtraction of like fractions are also follow the same rule as addition. Represent 2 by 5 on a paper strip. Represent 4 by 5 on another paper strip. We subtract the numerators and find the difference, that is 4 minus 2 is equal to 2, and represent on the strip as shown here. Thus 4 by 5 minus 2 by 5 is equal to 2 by 5. So the difference of two like fraction is equal to difference of numerators upon common denominator. So students, now let's look at example number 1. Subtract 5 by 9 from 7 by 9. So here also you can see there are two like fractions, since both have the same denominators. So we have to subtract 5 by 9 from 7 by 9. So let's start from 7 by 9. We have to subtract 5 by 9. So in order to subtract the two, what we need to do? First have a common denominator, that is 9, and subtract the numerators, that is 7 minus 5. So 7 minus 5 is 2. So our answer is 2 by 9. So this is the answer when we subtract 5 by 9 from 7 by 9. So I hope students you have understood how to subtract the two like fractions.